We already used this identity in one of the examples as we discussed the limit of complex numbers. We just simply use the idea of it to be true for the calculus concepts where we use x instead of z. This time, let's provide here additional proof that this is really true. Now, this time using the L'Hopital's rule. We have here the limit of your sine z over your z as z approaches to 0 equal to 1. That is actually the identity for this one here. Of course, this is 0 over 0 if we're going to try doing that, okay? Because as you substitute z approaches to 0, it will not be equal to 1. That's the use of this video. So we are going to show here the proof that L'Hopital's rule could be used here. So let's try to show that this is really indeterminate as z approaches 0. Of course, you have your sine 0 over 0. Your denominator is already 0. Your sine 0 is also 0 according to the angle in unit circle, indeterminate. Obviously, that's a determinate form. It's not equal to 1 here. But why is it is equal to 1 aside from the fact that a similar form using x's instead of z in the calculus is equal to 1? This is where the L'Hopital's rule may be used. Of course, let's take the numerator as f of z. That's our sine z. And then our g of z would be the denominator z. Let's take their derivatives. The derivative of sine z is cosine z. The derivative of your g of z, which is z, is equal to 1. Obviously, this is not equal to 0, and hence, together with the idea of the L'Hopital's rule, we can now use the ratio of the derivatives. Because we are told that the limit of the original functions, sine z over z, as z approaches 0, according to the L'Hopital's rule, since it resulted to indeterminate form, is just equal to the limit of the ratio of their first derivatives. The derivative of sine z is cosine z. The derivative of z is 1 as z approaches to 0. Obviously, our denominator is no longer 0. This is equal to cosine 0 over 1. And cosine 0 is 1 over 1, which gives us 1. Cutting all of this in the middle, according to L'Hopital's rule, hence, the limit of your sine z over z as z approaches 0 is obviously equal to 1. This was the target earlier. Need to show or prove that this identity is true, at this time using L'Hopital's rule. So previously, we just used the assumption of it being similar to the calculus concept. Now this time, using L'Hopital's rule, it has proven further that this is really equal to 1. Thank you very much for watching.